Hi there, everyone. So I know that this has probably been around, and this might be normal knowledge to some, but I was running into a problem where I needed to solve, a repetitive function over and over and over and over again. And by the time you've hand entered, Pythagorean theorem, or just the root of the sum of any square enough, you get a little tired of it too. As an electrical engineering student, though, we frequently have to run into combinations of things where we're adding up the sum of the inverses, such as when you parallel combination resistors, inductors, or do a series combination of capacitors. So essentially that looks like 1 over the root, or not the root, but the inverse sum of whatever it is you're adding together. So these can be any values. This is really cumbersome for TI-89 users because we have to essentially write x to the -1 plus y to -1 plus z dot 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 all to the -1 in order to accomplish this. However, we can create a user function in here, and you don't have to do any hard programming to do it. So I'm going to give you just a brief show on the calculator where the button is that we'll be using, and essentially how it's just going to look. So on your TI-89, in the bottom left, you're going to see this little button that says stow, short for store, and then above that is recollect. So you could press the second button and then recollect, and it will show you any variable that you have in there, and it'll spit out whatever the equation you have is. So for this guy in particular, you can say any equation you want to do. So like we'll just type it in exactly like you see it here. So we have x to the -1 plus y to the -1 plus z to the -1, all, skip over there. So as you can see it there, x to the -1 plus y to the -1 plus z to the -1, all of that raised to the -1. Now ordinarily you would have to go through user define under other and do all this, but this is actually a really neat shortcut. So you have all of this here. Now the trick here is you hit that button store, and what it's going to do is it's going to put that little arrow there. And this is the cool part. Now you assign it a variable that you want to use to recall it any time. Now it can't be anything that you used up here. So you could do alpha A, alpha B, alpha C, go through the line of whatever letters and symbols you want to use. But ultimately I'm going to use, we'll just say T to recall it. Now T is going to be a function of X, Y, and Z. So that arrow, and then just those functions. Now what this is going to do is it's going to store it. I'm going to actually name mine T4. You can do that too. You can call it T4, but obviously this is supposed to be a shortcut, so you don't have to make it super lengthy. All right, so once I hit enter here, it's going to say done, and you see the entire expression there that we just did. So x to the -1 plus y to the -1 plus z to the -1 all to the -1, so that now any numbers I choose to do, I say T4 of X, Y, and Z. So let's say my first resistor, we'll call them resistors, was 10,000. I then have a 50 ohm resistor, and then we'll just say 32K. Now, we would expect all of this to equal out something less than 50 because that's how parallel combinations work. You just hit equal and bam, it's already there. You don't have to go through that mess every single time. Now the implications of this are such that if you made a shorter version like I have, so in my calculator I just say T of 50 ohms, 30 ohms, boom, you have an 18.75 ohm resistor. This is useful because you can string that in series with another 50 ohm plus another 30 ohm plus another parallel combination of, we'll say 80 and 90. And just like that, you have full-on circuit analysis rapidly usable. So now obviously you can program this, but this works for any other thing you can do, and you can use logic. So even negative b plus or minus the square root of b squared minus 4ac all over 2a. Everyone's favorite quadratic formula. Now, if you wanted to program something like this in there, you would then say this is negative b plus or minus. So that or is important. So you would label out this entire equation in there. You know, you could say b, a, and c's for your variables, but it would essentially look something like this. You would have negative b plus the square root of all that inside all over 2a. And then you'd come over here, you'd have a space, and it would say or. You then say b minus all of the inside of the radical all over 2a. And then the one last quick tip for you there is that you would say solve. So the format of a standard solver is you would say solve. Pardon my handwriting. It'll give you parentheses, and it'll look like something like your expression x plus 10, comma, the variable you're solving for, and that'll be it. That's all well and good, but if you're doing the quadratic formula, you're going to want to know, especially if you're in engineering, if you have any unreal results, you know, whether you're doing eigenvalues or if you're trying to figure out complex ratios, etc., and doing complex factoring. So what instead, all you have to do is literally just put a C there. And it just stands for complex solve. So now, even if you have the square root of -1, you hit C solve, or we'll say, you know, that guy, all in the parenthesis, solve for x, it'll come out as, you know, I times the root of x, essentially. So, as you can see here, this is a very powerful tool. So I already stored the complex solver, so when you put it in there, it's going to look like C solve for minus b plus the square root of b squared minus 4ac all over 2a. Or you have b minus the square root of b squared minus 4ac all over 2a. And then you would say, comma, solve for x. That's the part I'm missing here, actually. X equals all this. So let me back up just a hair. Inside of this equation, when you say solve, you would say x equals all that mess first. So then you would use your a's and b's and c's. So here you would have x equals negative b, all that, or x equals all this, and then you solve for x. But then you just hit that store. You hit store, and then you say you want to use the variable x, and it's going to be with regards to a, b, and c. So then after that, all you have to do is just insert, you know, every, you know, just the a and b and c of your equation, you know, whatever they are, complex wise, what have you, and it'll spit it out every time. So here I have it sent in here as E. So E for eigenvalue, and then as it goes through, you just have 9, we'll say 10, and 3. So my A is 9, my B is 10, and my C is 3. I then hit equals, and it spits out imaginary numbers. So these are all in polar format, but here it is. It's giving me everything in that situation, which we expect. The A is much larger than the B. If I made that another 3, we have all real numbers. Now, one last note about this before you go on. If you do second and then variable link. What that's going to do is it's going to bring you to this screen. It'll probably have everything open here, but this is every variable you assign, all of them. So there's my T. And now you can manage this. You can delete it, copy it, rename it, move it, make even a folder for it. But the important part here is you archive the variable. And what that's going to do is it's going to free up some space on your calculator, but it makes it so you cannot delete it. So the only downfall to these, let me back out here, is if you decide that you're going to hit new problem. You know, you want to clean up your immediate RAM space, so you hit new problem and you're done. That would erase your brand new user function unless you archived it. So that's an important part of it. If you want to keep it, if you just want to label a generic equation each time, go for it. But if it's something you want to keep using, you want to keep paralleling or even doing the Pythagorean theorem of certain variables, it's really helpful. So I hope this helps. If you have any questions, put them in the comments below. And happy computing.